Hello, welcome back to the channel. So let's continue our previous videos and do one more question on calculating the indefinite integral of trigonometric functions over here. So in this question, we have to calculate the integral of e to the power x sine e to the power x cos e to the power x dx in this case. So again in this question, we see the same pattern over here, which we saw in the previous videos. We see sine and cos function together. It gives us an idea that if we solve this question using substitution, it might be the most favorable approach in order to solve this question. So let's try solving this question using substitution. And you'll notice that there are indeed three ways in order to solve this question over here. And the three ways are, since we know that sine and cos are derivatives of each other, so if we take u to be sine e to the power x, let's suppose, we know that if we take the derivative of u with respect to x, we'll get the differentiation of this, and then we'll use chain rule, right? Because we have a combination of functions, we have a composite function, so that is why we'll use chain rule in order to find the derivative of sine e to the power x, right? So if we calculate du by dx in this case, it would simply be the derivative of sine is cos. So it would be cos e to the power x, and then because of the chain rule, we'll have to take the derivative of e to the power x as well, which would be simply e to the power x, right? So if we calculate du in this case by shifting dx to the other side, it would simply be du equals e to the power x times cos e to the power x, right? And over here we will have a dx as well. And now we can clearly see that if we assume a u function to be sine e to the power x, we can easily convert this sine e to the power x to u. And also, since we know that our du is e to the power x cos e to the power dx, we see a e to the power x cos e to the power x term, right? So we know that this term can be easily converted to du in this case, right? So the integral in this case would simply be integral of u du, right? If you assume this approach over here. And since we talked about three approaches in order to solve this question, let's move on to the next approach. And now again we'll use the same property of the derivative of sine and cos functions. We know that the derivative of sine has a cos component and the derivative of cos has a sine component. So now for our approach 2, let's take u to be cos e to the power x in this case. And again, if we'll calculate the du by dx in this case, it will be the differentiation of cos e to the power x first, which would be minus sine e to the power x, and then because of the chain rule, we'll have to calculate the derivative of e to the power x as well, which would simply be e to the power x. And now again, if you'll calculate du by shifting dx to the other side, you'll clearly see that your du would be minus e to the power x sine e to the power x dx in this case, right? And now again the same approach. If you assume your u function to be cos e to the power x, this will be converted to u, and you also have an e to the power x sine e to the power x dx term, which is over here, which can be easily converted to minus du over here if you shift the minus to the other side, right? So again, if you'll solve this question using this approach, you will get the integral to be simply integral minus u du in this case, where your u is cos e to the power x in this case. So you'll have a different answer for the indefinite integral, but it would also be the correct answer in this case, because in indefinite integrals you can have multiple correct answers over here. And now again, since we talked about three approaches in order to solve this question, we also know that the derivative of exponential function is also an exponential function, right? So again in this question, we have an e to the power x component which has been repeated multiple times in the same integral expression, right? So let's assume, since our integral is e to the power x sine e to the power x cos e to the power x dx. Now let's assume for our third approach, let's assume our u function to be simply e to the power x in this case. So if you assume u to be e to the power x, you know that your du would be simply e to the power x dx in this case. So let's first rewrite this integral in a way such that it's easier to visualize what happens in the substitution approach over here. So we can write the same integral as sine e to the power x cos e to the power x e to the power x dx, right? I just shifted this e to the power x over to the last because we wanted an e to the power x dx term to be converted to du in this case, right? So now if we solve this question, we know that we have assumed e to the power x as u. So this would simply be sine of u cos of u, and then e to the power x dx will be just converted to du in this case, right? And we know another property of the double angle of sine functions. We know that sine of 2u is basically sine u cos u, right? This is the same concept that we also covered in one of the last videos. So we can simply use this formula in order to calculate the indefinite integral over here. So if we use this formula, our indefinite integral will be simply converted to calculating the integral of sine 2u by 2 du in this case. And then you can easily solve this question by taking the integral of a sine function, which you know would be a minus cos expression over here, right? So now you have indeed three approaches to solve this question, and you'll get three multiple answers. But as you know that in indefinite integral, you can have multiple correct answers. So it doesn't matter which approach you follow. Either you can follow this approach, or even this approach. Whatever seems to be the easiest for you, feel free to go ahead with that approach instead of following a complicated approach over here. And again, I'll leave all the integral calculations to you, because in this question, the most important thing was to discuss about the possible ways in order to solve this integral over here. So that's it for this video. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.